Welcome back to the deep dive. This is where we take the source material and really break it down, helping you get to true mastery of a topic fast. And if you're listening, you already know that the way we all shop is, well, it's changing in a fundamental way. We're moving past just searching and clicking. We're moving into what people are calling agentic commerce. And we're talking about AI assistants that don't just, recommend a product. They can actually run the entire transaction.
Oh, whole thing.
Yeah, the whole complex process, checking inventory in real time, factoring in pricing that might change minute to minute, securely applying your loyalty points, and then completing the purchase, all without you ever leaving that chat window.
It's the dream, right? That completely seamless shopping experience. But it's always had this massive structural roadblock in the way.
And that roadblock, that hurdle that's been slowing down innovation for the entire retail world is the fact that there's no universal language.
Exactly. Until every single retailer, every bank, and every AI platform are all speaking the same commerce language, those amazing seamless experiences just stay fragmented. They're too hard to scale up.
So today we are diving deep into the plumbing that's designed to fix all of that. It's called the Universal Commerce Protocol, or UCP for short. And our source material for this comes straight from the people who built it. We're looking at the Google developers blog entry under the hood, Universal Commerce Protocol, UCP. Our mission for this deep dive is to really unpack the UCP's architecture, which is very secure and very flexible. We're going to analyze the, frankly, stunning level of industry collaboration behind it.
And I think most importantly, we're going to explain exactly how this protocol shifts the entire shopping journey for you, the consumer, from that first moment you think, I need something, all the way to getting that verifiable purchase confirmation, all in this new age of AI.
Okay, so let's unpack this, and let's start with the core problem, because the source material frames it perfectly. Consumers now expect conversational experiences. They want to start with a really broad idea, like, I need a good suitcase for a 5-day trip to Seoul, but it has to be lightweight and, not too expensive.
Right, a brainstorming session.
Exactly. And they expect the AI assistant to just smoothly transition from that brainstorming right into a secure real-time purchase. And that kind of instant demand, it just requires infrastructure that, well, it really didn't exist before.
It didn't. And the underlying issue is the way integration has always been done, historically. You have every retailer, from the giants down to the smallest shops, and they've all built these highly customized back-end systems.
Systems for pricing, for inventory, fulfillment, checkout.
They've spent decades optimizing those systems for their specific business.
And then a new consumer surface comes along. It could be a mobile app, maybe a new buy button on a social media site, or now a really powerful AI assistant.
And every time, the retailer had to build a brand new, totally bespoke connection just for that one surface.
That's the legacy challenge. So if a major retailer wants to be part of this new agentic commerce world, and let's say there are 6 major AI platforms they want to be on.
Suddenly, they're looking at a massive developer project. They have to dedicate huge resources to building 6 completely different integration layers. They might be dealing with 6 different data formats, 6 different security protocols. It's a mess.
And this is what the source calls the NXN integration bottleneck.
That's the term.
Every business, which is one N, having to build a separate custom connection for every single consumer surface or AI assistant, the other N.
And it's not just that it's complicated. It's a massive brake on innovation. It just stops the rollout of these really cool frictionless experiences because the cost for the retailer to integrate is just too high.
And on the other side, the effort for the AI platform to onboard all these different businesses becomes totally overwhelming.
So the entire reason UCP exists is to collapse that end-by-end complexity, to boil it down to a single point of integration that's built on a common shared language.
Okay, so officially, what is it?
Officially, UCP is defined as an open source standard, and it provides that common language, and this is the key phrase, the functional primitives that are needed for commerce journeys to flow smoothly between, the consumer surfaces, the businesses, and the payment providers.
Okay, let's pause on functional primitives. That sounds very technical. So if UCP is the universal translator, what are the primitives?
Think of them as the basic standardized verbs of commerce. They are the agreed upon API calls and data structures that represent a single core action.
So instead of every company having its own unique way to say add to cart.
Exactly, or check inventory, UCP defines the standard primitive for that action. So A primitive might be an action called start checkout session or apply discount. It's the basic Lego brick of functionality that lets everyone talk to each other. It guarantees the AI agent always knows exactly what format to use, no matter if it's talking to Walmart or a tiny store on Shopify.
So it creates the sort of minimum viable vocabulary for a successful transaction to happen.
That's a perfect way to put it. And it's really smart because the protocol is designed for backward compatibility, which is absolutely essential if you want people to adopt it quickly.
Right, you can't ask everyone to throw out their old systems.
No way. The sources confirm UCP is built to work with existing retail infrastructure. And critically, it's compatible with the Agent Payments Protocol, AP2, for secure payments right from day one. This means businesses don't have to, rip and replace their entire payment system. They just need to wrap their existing capabilities inside the UCP framework.
Now, you mentioned those integration methods. The source talks about 3 different ways businesses can plug in. Why 3? Why not just one standard API for everyone?
Well, that flexibility is really the key to making it work for everyone. We have to address the different needs of modern retailers and also the fact that AI tech is evolving so fast. So the 3 methods are, 1, traditional REST APIs, which is, the standard way systems talk to each other.
Okay, the classic.
The classic. Then you have agent-to-agent, or A2A.
Yep.
And finally, the Model Context Protocol, or MCP.
And those last 2, A2A and MCP, they feel like the next generation stuff, tied directly to the AI. Let's define A2A first.
Agent-to-agent is basically a peer-to-peer communication standard built specifically for autonomous services. So imagine your personal AI assistant that handles your finances needs to talk to the retailer's specialized agent that handles pricing.
Okay.
A2A defines that structured, secure handshake between those 2 autonomous agents. It lets them negotiate, exchange information without a human in the middle clicking buttons or translating things. It's pure agent-to-agent talk, focused on getting an action done.
And what about the Model Context Protocol, MCP? How is that different?
MCP is where it gets really deeply integrated with the large language models themselves. Instead of the retailer's UCP system talking to a separate agent, like an A2A, MCP allows the retailer's commerce capabilities to be exposed directly inside the context window of the AI model.
Whoa.
Yeah. It means the model itself, the LLM that's powering the Gemini app, for instance, can natively understand and call on commerce actions based on the conversation it's having right now.
That feels like a huge difference.
Yeah.
A2A is like 2 distinct software programs having a structured chat. But MCP is more like you're actually teaching the LLM how to shop as part of the conversation it's already having with you.
You've nailed it. It completely bridges that gap between the conversational flow and an executable transactional action. And the beauty of UCP is that it supports all 3 methods. So whether you're a legacy retailer with a solid REST API or a cutting-edge AI platform using the latest LLM, UCP is truly that one integration point that solves the end-by-end headache for everyone.
It's one thing to talk about creating a standard, but in tech history, standards wars they're brutal. Usually one giant company tries to force its own proprietary format on everyone else.
Right.
What's so incredible about UCP, and the source material really emphasizes this, is the level of industry collaboration. This wasn't cooked up in a single boardroom. It feels more like a shared infrastructure project.
And that amount of buy-in, that breadth, is the loudest possible signal that UCP is solving a deep, fundamental shared economic problem. The cost of not having a standard and that end-by-end bottleneck, it had just become too high for everyone involved.
Let's just list some of the developers, because this is where you really see the scale of it.
Yeah.
UCP was developed by Google in collaboration with huge industry leaders. We're talking Shopify, Etsy, Wayfair, Target, and Walmart.
What's fascinating here is you have direct competitors all agreeing on the basic plumbing.
Yeah, Shopify and Etsy are fighting for the same small business market.
Fiercely. And Walmart and Target are, legendary rivals in retail. The fact that these giants are all sitting at the same table to build UCP shows, they all get it. They understand that the future money isn't in controlling the integration standard. It's in making sure their products are available wherever the customer happens to be talking to an AI.
It feels like a realization that if they didn't all agree on a universal language, the AI platforms might just go off and invent their own closed systems.
And they'll lock them out.
Right, locking them out or forcing them into even more complicated platform-specific integrations. So it's a pragmatic, even a defensive move to standardize that base layer. That's a spot-on analysis. They're basically de-risking the future for themselves. And the list of endorsers just drives that point home. It's over 20 global partners across the whole ecosystem. The list includes Adyen, American Express, Best Buy, Flipkart, Macy's, MasterCard, Stripe, the Home Depot, Visa, and Zalando. I mean, that list covers everyone. You have huge retailers, specialists like Home Depot, global platforms like Flipkart, and then the absolute titans of the payment infrastructure. When you get Visa and MasterCard, Adyen, and Stripe all on the same page.
It's because they see that this is how most transactions are going to be initiated by agents in the future. They recognize that.
So it's all about standardizing the secure payment part of it within these agent conversations.
It ensures that the transaction, no matter how complex or how much an AI negotiated it, still flows through the existing trusted and highly regulated financial systems.
Okay, so let's dig into the 5 key benefits that UCP brings to all these different players. I think we need to break down what each group really gains from this, starting with the businesses themselves, the retailers.
Okay, so the first and biggest benefit is for businesses. UCP lets them show off their unique products and services across all the new consumer interfaces, AI mode in Google search, the Gemini app, you name it. But the single most critical protection for them, the thing that makes this whole standard work for big companies, is that the business remains the merchant of record.
The merchant of record, or MRR?
Yes, and they keep total ownership of their core business logic.
You said this was huge earlier. Let's explain why that's so critical. Why is keeping that merchant of record status just a non-negotiable for any big retailer?
Because the merchant of record is the entity that carries all the legal and financial responsibility for the transaction. If the AI agent somehow became the MOR, the retailer would lose control over absolutely critical parts of their business.
Like what?
Well, for one, tax compliance. The MOR is responsible for collecting and paying the right sales taxes, which change from state to state, country to country. It's incredibly complex. 2, payment liability and fraud. They handle chargebacks, they detect fraud. Handing that responsibility over to some third-party AI platform is a risk no sane company would take.
And I'm guessing it's also about the customer relationship.
That's the third one. The retailer maintains that direct relationship with you, the customer, after the purchase. They own the data for loyalty programs, for handling returns, for future marketing. You can't give that up.
So UCP is really just a facilitator for the transaction. It helps the agent find the product and, negotiate the terms. But the second the money actually moves and the order is official, all the liability and ownership stays exactly where it was, protecting the retailer.
Precisely. The protocol is the pipe that the transaction flows through, but the retailer's own systems are still the final authority on inventory, on pricing, and on all the legal stuff. And that flexibility is even better because of the embedded option they mentioned.
Right, which lets businesses keep their own branded checkout page.
Exactly. So at the final step, you're not forced into some generic UI from the AI platform. You can still have your own custom, trusted checkout experience.
Okay, let's switch gears. For the AI platforms, what does UCP change for them?
For them, it's all about scale. It makes onboarding businesses dramatically simpler. I mean, an AI shopping assistant is basically useless if you can only shop at 2 or 3 stores.
Right.
UCP lets them tap into the inventory of every single UCP-compliant retailer almost instantly using one set of standard APIs. So they can scale their shopping feature from a handful of partners to thousands almost overnight. It's the thing that makes agentic shopping a real mass-market feature for their users.
And what about for developers?
For them, the big win is that it's open source. So instead of having to learn a new proprietary SDK for every single AI platform that comes along, they can contribute to and build on one shared, stable, community-driven standard. It just makes development faster and, frankly, it future-proofs their work. They can focus on building cool new commerce features instead of just building endless API bridges.
Okay, next group, and this is a big one. For payment providers, we're talking Visa, MasterCard, Stripe. The stakes here are highest when it comes to security and trust.
And the architecture is explicitly designed to give them that trust. It has an open, modular payment handler design, which guarantees there's choice and interoperability. But the real breakthrough, the core innovation here, is that it enforces universal payments that are provable.
Okay, provable is a word we have to dig into. What does it mean for an authorization to be backed by cryptographic proof of user consent?
Well, think about it. In this new world, an autonomous AI agent might make dozens, even hundreds of little decisions for you. It's picking the best price, the fastest shipping, applying discounts. In the old world, if something went wrong with a purchase, proving that the human actually wanted that to happen could get really messy.
Especially if your only record is, like, a line of text in a chatbot history.
Exactly.
Yeah.
So UCP fixes this by making the agent use something called verifiable credentials. It's basically a digitally signed token, a cryptographic receipt, that proves you, the user, authorize the agent to complete this specific transaction for this specific amount of money.
So it's a legally sound audit trail.
That's exactly what it is.
Yeah.
This cryptographic proof provides the legal certainty and the robust security that the financial world and the retailers need to be able to trust an agent. It's revolutionary because it builds that necessary layer of trust for transactions negotiated by a non-human.
It elevates the whole interaction from just a suggestion in a chat to a legally binding signed agreement.
It creates the trust.
Yeah.
And finally, that brings us to the consumers. For consumers, UCP means, yes, less friction, but it also means peace of mind.
The peace of mind that comes from that provable consent.
Yes. You can shop from your favorite stores, knowing the whole process is secure and, just as importantly, verifiable. And because the protocol standardizes how information is exchanged, the AI agent can now securely access and apply all your member benefits, your loyalty points, any special discounts you have, automatically.
No more digging through your email for a coupon code or trying to remember your loyalty number.
Nope. The agent speaks UCP, it sees the standardized discount extension that the retailer offers, and it applies it dynamically. It ensures you get the best possible value without having to lift a finger.
That complete analysis of the benefits, it leads us right into the architecture itself, the blueprint. Because to deliver on that promise of trust and scale, the protocol has to be, built flawlessly.
And here's where it gets really interesting, because the architecture is what determines if this standard will last. If it can't handle millions of secure transactions, it doesn't matter who bought into it, it's going to fail.
So the source material lays out 4 key pillars that define UCP security and its scalability. Pillar 1, unified integration, is what we've already covered. That's the mechanism that collapses the end-by-end problem. That's the whole foundation.
Right. Pillar 2 is the shared language. This is where UCP standardizes the entire life cycle of a commerce transaction. It defines the standard format for discovery, the schema for capabilities, which is what services a business offers, and the transport bindings, which is how you access them. This shared language is vital because it's what guarantees real interoperability across discovery, consideration, purchase, and even managing the order after the fact.
Okay, so if all the software speaks the same language, they're compatible. But pillar 3 is extensible architecture. Now that sounds almost like a contradiction. How can it be standardized but also flexible?
That's the central challenge for any modern standard.
Yeah.
If UCP was just a rigid protocol defined only by what commerce looks like today, basic checkout, product search, it would be obsolete in 6 months. The extensible architecture, which is built on these flexible capabilities and an extensions framework, is what ensures the protocol can grow and adapt with the market.
So if a totally new kind of delivery option appears, like, say, drone delivery in under an hour, UCP doesn't need a total version 2.0 overhaul.
Exactly. That new service, the rapid drone fulfillment, would be built as an extension that sits on top of the existing stable checkout capability. This modular design means UCP can easily expand into new areas, new business verticals, new countries, without breaking the core protocol that everyone else is using. It separates the stable foundation from the dynamic, innovative features.
And that brings us to pillar 4, the security-first approach. In terms of architecture, how is that achieved? It's achieved through 2 main things we've touched on: tokenized payments and verifiable credentials.
This approach is just essential when you have autonomous agents. Tokenized payments make sure that your sensitive credit card information is never actually exposed to the agent or potentially to the LLM's context window. Instead, a special one-time use token is used for the transaction, which drastically limits the risk if there's ever a data breach.
And the verifiable credentials.
As we discussed, that's what provides the cryptographic proof of user consent for every single transaction. It's the bedrock of trust between you, the agent, the retailer, and the bank.
Okay, let's go a little deeper into the language itself, the services, capabilities, and extensions, because that really dictates how a retailer plugs their business into this whole system.
This structure is what gives them really granular control. So at the highest level, you have services. This defines a broad business vertical, like shopping. A business will register which services they support. Then inside those services, they expose these core commerce building blocks called capabilities. These are the functional primitives we were talking about. The key actions like product discovery, checkout, identity linking, or order management.
And then the extensions are what add on to those capabilities.
Yes, the extension framework is what allows for real market differentiation even within a standard. So the core checkout capability might handle the basics, like price and tax. But a specific retailer could offer a very unique in-store pickup scheduling extension, or the discounts and loyalty extension that we're going to see in the demo.
Ah, so this is how a business can still offer its own unique value, its special features, and an AI agent can discover them through the protocol.
Exactly. And it doesn't force every other business in the world to adopt that same feature. It all depends on this dynamic discovery mechanism.
So how does that work? If a business launches a new in-store pickup feature tomorrow, how does my AI agent find out about it instantly and securely?
It's handled by a standardized profile. Every business publishes a simple JSON manifest file, which is basically a directory of their services, and it's always at a universally agreed upon location on their server.
So the agent always knows where to look. It always knows. It just queries this standard directory dust well known up. And the business instantly responds and says, here's what I can do. I offer checkout, I support discounts, I accept Visa, and here are the exact endpoints you need to call to use those services. It completely gets rid of the need for any pre-negotiated, hard-coded integrations. It's what really solves the complexity. Let's circle back to that payment handler model because the source says the separation of instruments from handlers is key. How does that model help it scale?
Right, so the model makes a clean separation between what the customer uses to pay, that's the instrument, like your specific MasterCard, or a digital wallet like Google Pay, and who actually processes that payment. That's the handler, which could be Stripe or Adyen, or the retailer's own internal gateway.
Okay, so if a brand new digital wallet, a new instrument launches tomorrow, why does that separation help UCP?
Because the UCP protocol only needs to know how to talk consistently to the handler, to Stripe, for example, using a standard interface. The new digital wallet might have a whole new way of interacting with the consumer, but as long as it gives the required standardized data to the handler, the UCP system doesn't have to change at all. It remains perfectly stable.
So the handlers are like universal adapters.
That's a great way to think of it.
Hmm?
They're adapters between the crazy, fast-changing world of consumer payment options and the stable, secure world of transaction processing. This architecture is what lets the system scale to handle a really diverse global payment landscape without needing a total rewrite every time a new fintech app comes out.
That's a really smart way to future-proof the money side of things. Lastly, on architecture, we mentioned the transports again, A2A, MCP, and APIs. Can you give a concrete example of why a business might choose one over the other for a specific capability?
Sure. Let's say we have a retailer with a really complex old inventory system. For their checkout capability, their top priority is stability and reliability. So they might choose the traditional REST API binding for that service. It's solid, it's predictable, and it's already secured by their existing corporate infrastructure.
Okay, makes sense.
But for their product discovery capability, where an AI model needs real-time, nuanced context about product features to make good recommendations in a conversation, for that, they might choose the MCP binding. This lets the large language model directly access and use their product information dynamically right inside its context window. It makes the recommendations feel much more contextual and human. UCP lets them mix and match the bindings based on what they need, giving them standardization with flexibility.
You know, it's one thing to talk about architecture and pillars, but it's another thing entirely to see the protocol actually work. The source material gave us a really detailed technical walkthrough, which I think is essential for understanding how this theory becomes a real seamless transaction.
Yeah, that walkthrough is great. It focuses on a simple scenario, a demo flower shop business that's implemented UCP and an AI agent that's trying to make a secure purchase. And we can just follow the 5 key steps that the developers laid out, which show the whole sequence, perfectly discovery, creating the session, and then modifying it. Okay, so it starts with the setup. Step 1 and 2, setup and preparation.
Right, this is all on the retailer side, getting their house in order. They start up a Python server that's running their business APIs, integrated with the UCP SDK. They populate a simple database for their products, in the examples of Bupi Osusys. And critically, that server starts listening for requests on a specific port 8182. This basically hangs a sign out that says, we're open for UCP business. So now the business is ready. The agent needs to figure out what services this flower shop actually offers. Step 3, dynamic discovery of capabilities. How does the agent start that process? The agent knows the rule. It's a standard rule. Every UCP-compliant business publishes its service menu in a specific known location. So the agent just sends a request to the server at the path. That well-known upbeat. That one simple request immediately eliminates the end-by-end problem. One URL tells the agent everything it needs to know.
And what does that JSON manifest file actually tell the agent about the flower shop? It tells it everything. It reveals the core service they support, which is dev.ucp.shopping, and then it lists the specific capabilities and the endpoints to access them. The most important capability, of course, is the core transaction one, dev.ucp.shopping.checkout. But it's not just checkout, right?
No, and this is where the agent immediately learns about the extensibility. The manifest also lists dev.ucp.shopping.discount and dev.ucp.shopping.fulfillment. And it explicitly says these are features that extend the main checkout capability.
So that's critical information for the agent.
It's huge. The agent doesn't just know it can buy flowers. It knows it can modify that purchase with a discount code and manage the delivery, all using standard UCP commands that it understands.
And it discovers the payment options at this stage, too.
Yes, dynamically. The manifest lists all the available payment handlers, which gives the consumer immediate choice. In the demo example, it lists com.shopify.shoppay, Google.pay, and a mock payment handler. And it's not just the names. The Google Pay entry, for instance, includes all the complex data the processor needs, the allowed card networks like Visa and MasterCard, the specific tokenization methods. The agent now has all the configuration data it needs to securely use any of those processors when it's time to pay. Okay, discovery is done. The agent knows the shop supports checkout and discounts. Now for step 4, invoking a checkout capability. The agent is ready to start the buying process. So to kick off the transaction, the agent sends a POS-T request to that checkout session's endpoint it just discovered. And this request is very structured. It specifies the line items, one red rose item with the product ID, bouquet roses, quantity 1, and some basic buyer info like John Doe.
But the most important part here has to be the security layer that's embedded in the request headers. This is what establishes the trust and the provability. What are the specific security mechanisms?
This is really where the security for agentic commerce comes to life. There are several mandatory headers that have to be there to make sure this session is legit.
Okay.
1, the UCP agent profile, which identifies which agent is making the request. 2, the request signature. This is the verifiable credential, that cryptographic proof that the human user actually consented to starting this purchase. 3 is the idempotency key.
And what's that for?
It's a unique one-time ID for this specific request. It prevents any network glitches or retries from accidentally submitting the request twice and charging the buyer double.
That idempotency key seems vital in a world of autonomous agents where a network lag could cause a real problem. It makes sure the transaction only happens once.
It ensures it's a single atomic event, absolutely. So when the flower shop server gets this secure, structured request, it processes it and creates a session. The immediate response it sends back is a detailed status update. It returns a unique checkout id, which becomes the anchor for this whole session, and it confirms the details. The initial price is 3,500 cents, or $35, and the status is set to ready for complete. The retailer's backend has now officially reserved the inventory and locked in the price, just waiting for the final go-ahead. Okay, now the agent remembers the user is eligible for a discount. So step 5, applying discounts, which demonstrates that extensibility. Right. The agent now uses the capability discovered back in step 3, the dev.ucp.shopping.discount extension. It sends a PUT request to the specific checkout session ID it just got back. So it's not creating a new session, it's modifying the existing one.
And all the agent has to do is provide the discount code, which in the demo is 10OFF. That's it. The UCP protocol takes care of all the complex backend stuff. The flower shop's own business logic applies the 10% discount, and the server sends back the updated session status. The response JSON clearly shows the original subtotal of 3,500, then a new line showing a deduction of 350 for the discount, and finally the new total amount due, 3,150. So that step right there proves the power of UCP's extensible architecture in a real transaction. The agent used a standardized command to apply a very specific business function, a discount, all within that secure ongoing session without needing any custom clone or forcing the user to leave the conversation.
And it's important to stress, as the source does, this is just one example, this exact same structured workflow would apply to all the other commerce actions. Applying your loyalty points, updating a shipping address, checking on an order status. It's all managed through standardized UCP capabilities like identity linking and order management.
This deep dive really confirms that UCP is an open standard, that it was built collaboratively. But Google was the one that initiated the project, and they provided the first reference implementation. What does that mean for how quickly this gets adopted? And, what's in it for Google to lead the charge here?
Well, even though UCP is vendor agnostic, having a giant like Google build the first reference implementation is strategically critical. It provides immediate, concrete code that developers can actually use, which massively lowers the barrier to entry. By defining that initial reference architecture, Google is really setting the pace and the technical tone for how agentic commerce is going to work in the near future.
And for you, the consumer, where are you going to see this new frictionless experience pop up first?
The Google implementation is explicitly designed to power purchases directly from eligible businesses right inside Google's main conversational experiences. The sources specifically call out AI Mode in Search and the Gemini app as the first places you'll see it.
So that means the whole path to buying something changes dramatically. Instead of searching, clicking a link, landing on a website, navigating some clunky checkout process.
The whole transaction can be finished right there in the search results page or in your chat window.
And Google is using UCP to make that as smooth as possible.
Exactly. Because the protocol supports open payment and wallet providers, Google's implementation lets consumers use the payment and shipping info they already have securely stored in Google Pay and Google Wallet.
And that's the moment the friction just drops to almost zero. The agent can securely pull that tokenized payment method and your address from your wallet and then send it through the UCP framework to the retailer.
That's exactly right. The agent does all the boring work of filling out forms, but it does it securely and with that verifiable consent we talked about. It leaves you, the consumer, just needing to give the final okay on the discounted price. That transformation from find me a product to your purchase is complete within a single interaction. That's the core value UCP unlocks for everyone.
Okay, so if I'm a business owner listening to this right now, and I want my products to be available for purchase by agents in AI mode in Search or in Gemini, what do I actually have to do to integrate with Google's implementation?
The source material lays out two core requirements that are basically the gatekeepers. First, the business has to have an active Merchant Center account. And second, the products in that account have to be explicitly flagged as eligible for checkout.
Why is the Merchant Center account so critical? What's the connection?
Well, the Merchant Center is Google's verified central database for product information. It has inventory counts, detailed descriptions, high-res images, verified pricing. An AI agent can't negotiate and finalize a purchase if it's working with uncertain or unverified data. The Merchant Center acts as the single source of truth that feeds the agent the reliable, real-time data it needs to do its job accurately and securely within the UCP framework. If your data isn't in there, the agent can't complete the purchase.
So integrating with Merchant Center is no longer just about getting your products listed in search results. It's now a functional requirement to be transactionally discoverable by an autonomous AI agent using UCP.
It's the requirement for data reliability and trust. And finally, the sources really stress the long-term vision here. UCP isn't a finished product. It's a living, breathing standard.
The call to collaborate is very clear.
Absolutely. It was co-developed, it's endorsed by over 20 global partners, and the invitation is open to everyone, platform architects, developers, businesses. Join the community. That means go explore the specification on the GitHub repository, get involved in the GitHub discussions to help shape what comes next, and actively contribute code through pull requests. The long-term success of UCP really depends on it staying an open, shared standard that can evolve faster than any single company's proprietary solution ever could.
So this deep dive has really shown us that the Universal Commerce Protocol, it isn't just a new set of APIs, it's the entire industry's unified answer to that crippling structural problem of end-by-end integration. By building a universal security-first language for commerce and enforcing it through tokenized payments, and that crucial cryptographic proof of user consent, UCP, is providing the foundational trust layer that's needed for truly secure and seamless agentic shopping.
And we've broken down how that architecture protects the retailer by making sure they stay the merchant of record, while at the same time it's eliminating all that friction for the consumer by letting agents dynamically apply benefits and use their digital wallets. And the design itself is inherently extensible. It's built not just for the shopping we do today, but for the complex, multi-step services of tomorrow.
Which raises a final, and I think a really provocative question for you, our listener, to think about as you finish this deep dive.
We know UCP provides this standardized, provable, and dynamically discoverable framework for basic commerce. And we know its architecture is explicitly designed to expand into new verticals, way beyond just buying products. So, given its ability to handle complex sessions and verifiable consent, what are the most friction-filled, high-stakes, multi-step consumer services? The the services that right now require endless forms, endless verification, and human intervention, that this new unified agentic architecture could fundamentally transform next.
Think beyond just retail.
Exactly. Imagine the coordination it takes to plan a complex multi-vendor vacation. Flights, hotels, specialized tour bookings, all dynamically priced and instantly booked with verified financial and identity consent. Or think about the highly regulated world of managing personal health services. That requires multi-party consent for scheduling appointments, for verifying insurance, for managing referrals, for prescription fulfillment. UCP provides the standardized, provable blueprint for agents to handle those incredibly complex transactions. The future of AI isn't just about buying a suitcase. It's about managing your life, one verifiable transaction at a time.